All right, ladies and gentlemen, this is the video on the distinction between sigma and pi bonding. This is something that you could get from reading the textbook. This is in the back of the chapter in chapter 9, or you could watch this video. Sigma versus pi bonding. When we talk about types of bonds, we're used to saying things like polar or nonpolar, single versus double versus triple. Sigma versus pi bonding is getting into what makes a single bond different from a double bond, what makes a double bond different from a triple bond, and going simply beyond the number of times they're connected. Because the thing is, the more times you connect atoms, they're not necessarily connecting the same way every time. And that's what sigma versus pi bonding is getting to. Sigma bonds are one type of connection that we get between two atoms in a covalent bond. And sigma, it's the Greek symbol sigma. That's how you pronounce this thing right here, sigma, written like that. Sigma bonds are the overlap of orbitals between nuclei. Now, you're probably saying, no, Mrs. Julian, aren't all orbitals overlapping between nuclei? My answer is actually no. When I say between the nuclei, I mean in the plane of between the nuclei. I mean directly in between them. I mean, like, you've got atom A and you've got atom B. These are the nuclei. Your sigma bond is directly between them. This will be your sigma bond. And because the sigma bond is directly between them, and it's what we're used to thinking of when we think of a bond, something that is occurring between the nuclei, it is the first bond that is formed. The first bond that you form between two nonmetals when they're sharing electrons will always be a sigma bond. What does that mean? All single bonds are sigma bonds. Well, that's actually kind of handy. Single, sigma, S and S. All single bonds are sigma bonds. It's the first bond that's formed. It exists in between the plane of the two nuclei. And what orbitals are involved in sigma bonds? Well, it can vary. It can vary. It will depend upon the hybridization of the two atoms. And this is why I'm recommending that you watch this video once, at least concurrently with the orbital hybridization discussion in class. You can certainly read ahead about orbital hybridization for this, but it deals with issues of hybridization. It sort of comes afterwards. You could have s orbitals involved in sigma bonds. You could have sp2. You could have sp3. You could have sp3d orbitals involved. But it's typically hybridized orbitals, because typically our central atom will have to hybridize at least somewhat in order to form bonds. Really, the only atom that comes to my mind off the top of my head that doesn't hybridize when it bonds is hydrogen. That's only because it has just one s orbital, and that's it. Multiple bonds. Well, thing is, once you form a sigma bond between two atoms, you actually don't form a second sigma bond. You've already connected them between the planes, directly between the two nuclei. You can't do that a second time. You've already used that space once. So in multiple bonds, double and triple bonds, only one part of basically half of the double bond and just 1/3 of the triple bond, meaning 1 out of the 2 times that they're connected in a double bond and only 1 out of the 3 times that they're connected in the triple bond, only one of those is a sigma bond. The other connections that are made in a multiple bond are what we call pi bonds. And yes, this is the pi from math class. A pi bond is a connection between atoms, between nuclei, that is actually not directly between the two nuclei. It is an overlap of orbitals both above and below the nuclei. So if we think about nucleus 1 and nucleus 2, the sigma bond would be directly between them. Above and below, if they are connected, that's the pi bond. And by the way, this is just one pi bond. The connection is both above and below simultaneously. Pi bonds use p orbitals. That's why the connection is both above and below simultaneously. because p orbitals have a shape like this. The second and third bonds in double and triple bonds are pi bonds. The first bond is a sigma bond. So it's the double bond is two connections between your nuclei. One of them is what we call a sigma bond, the other is what we call a pi bond. Sigma bonds use hybridized orbitals very typically. Pi bonds do not. Pi bonds use p orbitals. Pi bonds use p orbitals. Pi bonds use p orbitals. Single bonds are sigma bonds. Single bonds are sigma bonds. We do have some nice alliteration that we can use here. Mnemonic devices. The p orbitals that are involved here are those that are not needed in hybridization. Meaning you had a situation where your carbon only needed to hybridize 3 orbitals. So it threw into the blender an S and 2 P's, and it blended them all up and it made sp2. You still have that extra p orbital left over. There are 3 p orbitals. So who cares if your carbon didn't use it? It's still there. It's still left over. That p orbital can participate in pi bonding because you didn't hybridize it. So what would we use to make these pi bonds? We use additional p orbitals that were not hybridized. C2H4 is an example of this. C2H4 uses exactly what the example that I just said. The carbon takes an S and 2 P's, uses those for hybridization. It has 1 p orbital left over. These sp2 hybridized orbitals, these will participate in sigma bonding. The p orbital will participate in pi bonding. Pi bonds are what go into double and triple bonds. Sigma bonds are the first connection that you make, and they're single bonds. So this probably is the most important slide in my discussion of sigma versus pi bonding. I've got a few additional slides after this, but this is really what you need to know. Sigma bond versus pi bond occurs in, you will find sigma bonds anywhere that you have a bond, regardless if it's single, double, or triple. It's always going to be there. It's the first connection that's made. So sigma bonds occur in every single covalent bond. If it's a single bond, it's a sigma bond. If it's a double bond, one of those bonds is a sigma bond. If it's a triple bond, one of those bonds is a triple bond. Pi bonds, where do pi bonds occur? Pi bonds occur in double bonds and triple bonds. So you don't see them in single bonds, just double and triple. Number of bonds that form between atoms, meaning how many sigma bonds can we make between two atoms? We can only make one sigma bond between two atoms. That's it. You make one and then you're done. You can't form a second or third. Pi bonds, on the other hand, you can have multiple pi bonds between atoms. You can have, in the case of a double bond, you can have one pi bond. In the case of a triple bond, you can form 2. Results from the overlap of what? In the case of sigma bonds, what orbitals are overlapping? Either s orbitals or hybridized orbitals. It might be both. In the case, if you consider hydrogen bonding with carbon, your carbon is probably hybridized, your hydrogen is not, so that might be a case of s orbitals overlapping with sp2 orbitals to form a sigma bond. That could happen. So that's why I say and or. S orbitals and or hybridized orbitals. Pi bonds only result from the overlap of p orbitals. That's it. We do not see any kind of s or sp2 or sp3 or d at all involved in pi bonding. Physically occurs, meaning where is it located? The sigma bond is located between the center of the two atoms. It's directly linking the two atoms together. The pi bond, on the other hand, exists above and below the plane of the two atoms. If you've got 2 pi bonds, it will actually be in front of and behind. So if you can sort of picture, the pi bond is almost surrounding the sigma bond on all sides. And it's above and below the plane of the two atoms at the same time because it's p orbitals and because p orbitals have that shape. So above, our nucleus is in the middle. It's above and below the nucleus at the same time for just one pi bond. Sigma versus pi bonding, just to be very, 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 very clear, a single bond contains one sigma bond. They're synonymous with one another. That's what's forming, that's how the atoms are connecting when you make a single bond. And the sigma bond will be due to the overlap of s and or hybridized orbitals. A double bond contains one sigma bond and one pi bond. The sigma bond is addressed above as to what orbitals will be overlapping. The pi bond is due to the overlap of p orbitals that were not used in hybridization. And a triple bond contains one sigma bond and two pi bonds. So we only ever get one sigma bond, and if we're doing multiple bonding, the rest of the bonds will be pi bonds. Some examples, just to show you. We've got ethene and ethyne, our two carbon multiple bond species. In the case of ethene, this first one right here, we've got this H2C double bond CH2. In the C double bond C bond, we've got one sigma, one pi bond, because this carbon is sp2 hybridized, this carbon is sp2 hybridized, one pi bond. Each carbon has one empty, well, not empty, one p orbital that was unhybridized. So each of them has p orbitals. So they're like, hey, let's overlap our p orbitals and form a double bond. Yeah, sounds like a great idea. In the case of ethyne, right here, HC triple bond CH. In the case of the triple bond, just looking at the triple bond, it's one sigma and two pi bonds. It's two pi bonds here because the hybridization on this carbon is just sp, and this carbon is also just sp. So in this case, each carbon has two p orbitals that are unhybridized. So because each of them has two unhybridized p orbitals, it can form two overlaps of p orbitals, aka two pi bonds. Looking at this picture, this is ethene. Ethene is another name for, ethylene is another name for ethene. We see, this is our carbon. This is showing the sigma bonds right here. These are our sigma bonds. So this is our sp2 hybridized carbon. This is our sp2 hybridized carbon. You'll notice there are 3 electron domains right around the carbon. These are the 3, 1, 2, 3. In our hydrogen, it only has an s orbital. It didn't hybridize at all. So that's a sigma bond. That's a sigma bond. Sigma bond between the 2 carbons. Sigma bond here and sigma bond here. But we also have the pi bond, and that's right here. The pi bond, this is the same structure, same exact structure, but it's just showing different orbitals. We have our sp2 orbitals up on the top, and then in this figure that I've starred, we have the unhybridized p orbitals. This is the pi bond, showing the overlap above and below the plane at the same time of the p orbitals. And yes, they have to move close in orbit. They're not magnetically attracted to one another, but the atoms do move close enough so that these orbitals can overlap. So this last sort of picture, what it's showing right here, we have the pi bond above and below the plane, electron density above and below the plane of the nuclei, whereas all the sigma bonds are in between the atoms. So if you have a look at this picture, because pi bonds exist both above and below at the same time, this is one pi bond, just one. This is not two, above and below at the same time, because p orbitals are both above and below at the same time. And then we have 1, 2, 3, 4, 5. There are 5 sigma bonds. That's not a 56. That's a sigma. 5 sigma bonds in this structure. This is the showing the concept of the plane again, showing that we have the p orbitals above and below the plane, and then our pi bond right here existing above and below the plane at the same time. So that's the discussion on sigma versus pi bonding. If you look at that chart, that's really everything that you need to know distilled down. Sigma, single, pi bond, p orbitals seen in double and triple bonds. That's really the biggest thing that you need to know. A common question that can be asked, how many sigma, how many pi bonds in the structure?